Good morning. So for the subject data science in healthcare, today's topic under discussion are from Unit 5, starting with natural language processing, concept extraction, beyond concept extraction, clinical NLP tools, commercial clinical NLP tools, key differences between NLP and other applications. So coming to natural language processing in healthcare, it refers to a collection of data science and machine learning techniques that will let the computer understand, analyze, interpret, generate human language. In healthcare, NLP plays a critical role because over 80% of the clinical data is unstructured. Why the data is unstructured? You have clinical notes, discharge summaries, radiology and pathology reports, physicians' narratives, patient feedbacks, and complaints. NLP will be enabling extraction of structured computable information from this free text data. It will support in clinical decision support, population health analytics, medical research, operational efficiency. Coming to text indexing and search in healthcare data. In healthcare, you have massive volumes of textual data. So you need indexing and retrieval of this data efficiently. For what? For clinical audits, for case-based reasoning, for research code identification, for fast search across EHR system. This will be achieved through search and indexing engines built on NLP concepts. For example, you have Apache Lucene. Okay, it's a text search library. What is its role? Tokenization, inverted index creation, term frequency, inverse document frequency scoring, full text search in clinical notes. Lucene forms the core engine behind many healthcare search systems. You also have Apache Sol R. It's a platform built on Lucene. The use cases for this are searching EHR repositories, indexing pathology and radiology reports, facilitate search, near real-time indexing of clinical updates. Sol R adds REST APIs, scalability, and schema management. So you also have Elasticsearch. It's a distributed scalable search and analytics engine built on Lucene. What are the applications? Clinical text analysis dashboard, symptom and diagnosis search across millions of nodes, monitoring adverse drug events, population level text mining. So Elasticsearch basically supports real-time indexing, distributed storage, and analytics. Now coming to the pipeline of NLP in healthcare, you have text processing, tokenization, stop word removal, lemmatization, medical abbreviation expansions. Then you have clinical concept extraction, diseases, symptoms, medications, procedures. Then you have entity normalization, mapping term to standard vocabularies like ICD, SNOMED, RxNorm, indexing and retrieval, storing process text in Lucene, Solar, Elasticsearch, advanced modeling like transformer-based NLP, clinical language understanding. Coming to transformer-based NLP in healthcare, so they are the mechanism used to understand context, semantics, and long-range dependencies in clinical text. Examples: understanding negations, for example, no evidence of pneumonia; capturing temporal context like history of diabetes; clinical summarization; risk prediction notes. Transformer models trained on medical corpora outperform traditional NLP in accuracy and robustness. So NLU, it focuses on enabling the system to comprehend the meaning of a clinical language. So tasks are NER, diseases, drugs, procedures, relation extraction, drug adverse event relationship, intent detection in patient queries, clinical coding assistance. Examples: patient denies chest pain but reports shortness of breath. This implies what? Absence of chest pain and presence of dyspnea. Natural language generation in healthcare. What it will be generating is human readable clinical text from structured data. What are the applications? Your automated discharge summaries, radiology report generation, patient friendly explanation of lab results, clinical decision support narratives. So what NLG basically achieves is it improves clinical documentation efficiency and patient communication, reducing physician burnout. Now coming to the role of NLP in data science. Suppose the area is data integration. It converts unstructured text into structured features. If the domain is predictive modeling, it uses clinical nodes for risk prediction. For population health, it identifies disease trends from narratives. Explainable AI provides textual evidence for predictions. Clinical research enables cohort discovery from free tests. So this is what is the role of natural language processing in data science healthcare. This is what is the topic, natural language processing. And coming to NER. NER stands for named entity recognition, and you also have concept extraction. So what healthcare will be doing is generating a lot of unstructured data now, which may have clinical notes, summaries, diagnostic reports, prescriptions. So for better analytics, for better billing, research, decision support, these texts should be converted into structured representation. Structured representation. So in data science in healthcare, this transformation is achieved with the help of NLP, using the technique called as named entity recognition, concept extraction, text normalization, medical ontology model. Coming to named entity recognition, what it does is it identifies and classifies important entities in free text clinical data. What are the common healthcare entities, symptoms, medications, laboratory tests? For example, there is a sentence, clinical sentence called as patient is diagnosed with diabetes and prescribed metformin. Now, what will be the NER output? The disease is diabetes and the medication is metformin. Basically, NER forms the foundation for clinical analytics, coding automation, and downstream machine learning models. Coming to concept extraction in clinical text. So, what concept extraction will be doing is it will be focusing on identifying the clinical meaning behind terms. So, what are the key features of concept extraction? Handles synonyms and abbreviations, resolves medical ambiguity, maps text to standardized clinical concepts. Say for example, you have paracetamol and Tylenol. Though they are different, they are same medication. Now, what concept extraction will be doing is it will be mapping both to a single standardized concept. So, and this capability is very critical for accurate analytics, interoperability, and reporting. Coming to text normalization, stemming, and lemmatization. So stemming, what it does, it will be reducing words to their root forms. For example, diagnose and diagnosis, the root form is diagnose. Okay. Coming to lemmatization, what it will be doing is it will be converting words to their dictionary based form. For example, prescribed and prescribing will be going for prescribed. Now, normalization improves entity recognition accuracy and search effectiveness. Coming to medical coding using NLP, you have ICD-10 and CPD. ICD-10 is International Classification of Diseases 10th revision. It is used for diagnosis, disease classification, epidemiological analysis. CPT coding is current procedural terminology. It is used for medical procedures, diagnostic services, billing and reimbursement. Role of NLP. It automatically identifies diagnosis and procedures from clinical notes, suggests relevant ICD-10 and CPT codes, reduces manual coding efforts. Coming to UMLS, it stands for Unified Medical Language System. Okay, it's a knowledge-based medical knowledge base. Okay, it is used to integrate multiple healthcare vocabularies. What are the components? You have meta thesaurus, you have semantic network, you have lexical tools. So it achieves interoperability, resolves synonymy, supports advanced clinical analytics. MetaMap, again, it is used for clinical concept mapping. It's an NLP tool. What it does is it maps biomedical text to UML's concepts. Functions of MetaMap are identifies medical entities, maps them to UML's concept, identifies, handles spelling variations, abbreviations. What is the workflow? The input given is clinical node. So MetaMap starts processing. Output is UMLS linked medical concept. So if you look at the contribution of NER, it will be used for identifying clinical entities. Concept attraction captures true meaning. Coding enables billing and reporting. UMLS and MetaMap ensures standardization. Normalization improves model accuracy. Coming to few questions related to these topics, let us look at the list of questions, very few though. Give me a minute. Yeah. So we understood what is the role of NLP in healthcare analytics, right? So we have understood what is concept extraction and what is its importance. We also know the difference between clinical NLP and general NLP because we know that clinical NLP is more domain specific and requires curated medical ontologies. Now coming to few of the clinical NLP tools and their commercial solutions, you have CTEX, MetaMap, which we discussed, Medley, then you have Epic NLP, then you have IBM Watson Health, Amazon Component Medication. These are few. Coming to future direction in healthcare analytics, future trends include explainable AI, federated graph learning, multimodal analytics, integration with digital twins, ethical and responsible AI. So with this, I'll stop. Thank you.